Welcome back. Now we have been talking about different language APIs which are being supported in Spark. If I ask you a question whether the Spark is a program language on its own or not, yes, it is. Spark is a programming language on its own. So, when we have a programming language on its own, it is bound to have its own types, right? So, what is happening here is Spark is a programming language on its own. That is the first thing which we already know, and it has an engine called Catalyst engine. So, this particular Catalyst engine maintains the type information through planning and processing of the work. Whatever the work which is being done, it may be planning of the execution or execution itself, this Catalyst engine is maintaining the type information. Because the Catalyst engine is maintaining the type information, this in a way leads to the variety of the optimizations within the Spark. What does that mean? We'll come to understand that in the future classes. But let us take an example now. So now you have a Python and R. So we already understood through Python and R we can work in the Spark. So you are trying to handle the structured API of Spark through Python and R. Even though you are trying to code in Python, code in R, those are in turn converted into Spark types. Those are the ones which are going and getting executed as a part of the execution. So Spark has its own types because Spark is a programming language on its own. And also one important thing is Spark is a programming language on its own, and also it is also supporting the different languages like Scala, Java, Python, SQL. These are the different languages which are being supported by the Spark through the language APIs. Now what is happening is Spark has its own types, and also obviously each of the programming languages, they do have their own types. What is happening here is there is a direct mapping between the Spark types and also the each of the language APIs, so that the Spark will be able to recognize, translate that, and also execute the data processing tasks. So let us try to see a couple of examples here. For example, now here trying to see how Spark types are mapped with the Scala types. For example, here this particular first column is of the Spark data type and the second column is of the Scala type. So if you see byte, if you refer as a byte in Scala, that is directly mapped to byte type in Spark type. So same is the case with int is mapped to integer type, long is mapped to a float type, double is mapped to double type, so on and so forth. One of the very important aspect what you have to observe here is most of the Spark data types more or less matching with the Scala types. What may be the reason? You already know the reason. Because the Spark itself is built on Scala, right? That's the reason. Moving on, let us try to see a couple of examples in Python. How the Python types are mapped with the Spark types. In case of this is a Spark data type and this is a Python one. Okay. So int are long with a 1 byte in integers with a range of 1 minus 128 to plus 128 will be a byte type here. Okay. Like this, each of the types in Python have a direct mapping with the one more type in Spark. This is how Spark is able to do the optimizations really well. This is one of the important aspects of the getting a good performance in the Spark. Thank you.